All right.
Yep, we got a nice big group coming in today, so we're just letting everybody get into the room. So get the gang all here.
Good, good. I like to see everybody's faces on camera. Got a lot of people here today. 51 so far. Most of the time I'm not like right by my computer when I start this. I'm like back by my demonstration table doing stuff. But I'm going to start sharing stuff. Can't do the project, that's fine. I have some things that you can either watch me do, or we can do, I have something that I think you can do as another virtual demonstration, like what we did on our first day with the circuits. So I can introduce that.
And don't forget, these are recorded, so you can always go back and watch the video again when you do get the materials, and then you can do the activities in the lesson watching the recording.
Yes.
All right, so we still got some folks joining us. So let's get them all in here. Now we're up well over 50. Is this anybody's first camp? If this is your first camp with us, go ahead and type in chat. Let us know if this is your first camp. I have a feeling most of you are experienced campers at this point, but if we have any fresh faces, we want to make sure that we say hello. Oh, do we have a fresh face here? Nathaniel, are you new? Welcome. Welcome to your first camp. This is going to be a good one because, as Mr. Cleary said, we're going to be talking about food today, and everybody loves food. So we're going to talk about that. Abby, this is your first year. I hope you're having a good time. Let's see. Nilla is new. Welcome, Nilla. Nate loves to cook. Nice.
I love to cook too. And I always tell people I love to cook. But the secret is, as much as I enjoy cooking, what I really love is to eat. And you got to cook something to eat something. So I learned to be a pretty decent chef, if I say so myself.
What's your favorite thing to cook, Mr. Cleary?
My favorite food, hands down, nice big plate of loaded nachos. With you got all the fixing with your tomato, your salsa, your sour cream, your avocado, your chicken, your beef, your lettuce, your tomato, your beans, your guacamole, just your cheese. Fantastic.
Okay, that. Who's hungry now? Thank you, Mr. Cleary. All right. So I think we've got just about everybody in this session now. I just got, I think, our last waiter in. So we're going to go ahead and get rolling. You guys probably haven't met me yet unless you came to my Yarn Star activity last week. I am camp counselor Andy. I am going to be our host for today. You guys who have been with us this week, you know Mr. Cleary, and you know that he knows what he's doing. So we mentioned a little bit earlier that we're going to be talking about food today. And have you ever thought that food is science? So we're going to think about food as science today. And I asked Mr. Cleary what he likes to make. Why don't you guys tell us real quick in the chat? Do you know how to make anything? Tell me if you know how to make anything. Like maybe, do you know how to make microwave popcorn or some scrambled eggs? Do you know how to make a turkey sandwich? What do you know how to make? Got some scrambled eggs in there. Iggy helps mom. Oh, Layla. Mac and cheese. That's awesome. Pancakes. Pancakes are not easy. Philly cheesesteak pasta. Sign me up for that. Oh, yum. Eggs, toast, right? Chicken mac and cheese, cereal. You guys are great. You know how to make all kinds of stuff. So think about that. Yeah, think about the foods that you make when Mr. Cleary goes through his lesson today. So I'm going to hand it off to the expert, Mr. Cleary. And I think we're already recording, so I don't think I have to worry about that. So take it away, Mr. Cleary.
All right. Get my chat back up here. So today is going to be focused on temperature and thermodynamics. Does anybody know what the word thermodynamics means? It's a study of what? Temperature, yes, the study of temperature. So it's kind of, my title is a little redundant. It's temperature and the study of temperature. Thermodynamics is the science of temperature and essentially studies how heat moves through different substances. So some substances, we call those conductors. They allow heat to move through them very, very easily. Other substances do not allow heat to move through them very easily and are insulators. So what are some examples where you would want something to be a conductor of heat, to attract a lot of heat? Right, metal, when you are cooking, yes, you want your stovetop to conduct heat because that's going to heat up your pan, or your pan itself needs to be able to conduct heat to get the heat to the food that's warm. Microwaves. Microwaves are going to actually keep heat in. The sun, some things you might want to absorb heat from the sun. Have you ever thought why our roads are black? Because it's not just like roads were black and that's it. That was a very conscious decision to have roads all be black, because black is a color that's a really good conductor of heat. It absorbs heat. And if you have something like snow or ice, you want that snow and ice to melt off the roads. How about some situations where you want something to keep heat in or be an insulator, where you don't want it to attract a lot of heat? Oven, yes. You want the oven to keep the heat inside of the oven. Or keeping leftovers. What do you keep your leftovers inside of? Yes, fridge or freezer. So that all has got to keep heat, not in, but out, because you got to keep all the cold stuff inside of it, right? So all that is going to be made intentionally so that heat cannot pass through it easily. Can you imagine if you had a refrigerator that was made out of like some black metal and absorb heat very well? All your food would go bad in the fridge. There'd be no point in having a fridge or freezer. Now, you are probably familiar with, one way or another, are three different states of matter. You have a solid, is any material that is probably, hard to the touch. When we think of the molecules in a solid, they are packed tightly together. So I see some people saying they are frozen. Solids are, yes, they are considered to be frozen. Even if it is not super cold, anything that is solid is in a like frozen state. And particles don't really move around each other in solids. They may just kind of sit there and vibrate, but they're going to retain this shape. This pen is going to stay pen shape no matter what I put it in. If I put it in a cup, or if I put it in a jar, or if I put it in a bowl, it will not take the shape of the bowl or cup or jar. It will stay pen shaped. And I saw somebody saying liquids are very nice. Liquids are things like water or anything you drink. And most liquids we associate with are based around water, but not all liquids are. Like some oils are liquid, even though they're not water. But liquids has the particles that are kind of slowly rolling around each other, moving about. Particles in a liquid are going to float easily and move or slide past one another. And liquids also assume the shape of their container. If you take some liquid and you pour it in a cup, it is now cup shaped. If you pour it in a bowl, it is now bowl shaped. If you pour it in a tube, it is now tube shaped. And our next state of matter is gas. Gas particles are going to bounce around very wildly, like all these little tiny bouncy balls that are bouncing off each other in the walls and other surfaces. They are very well separated with no regular pattern, and they move freely at high speeds. So you may not be able to feel it right now, but you are surrounded by gas right now because the air is in a gaseous state. And you might not feel it right now, but if you move your hand very quickly, you can like feel the wind rushing past your hand. All of those are particles of gas that you are moving and pushing about. And I just got everybody to do this on camera, which looks very silly. Let's check my mouse. So I mentioned today we are going to be making ice cream. Ice cream relies on, or at least the way we're going to make it, relies on having a state of matter change and a temperature change. So temperatures can cause objects to expand or contract when you heat them or let them cool. They can cause matter to change their state, and they can cause chemical reactions. I'll go back. And they can cause chemical reactions. So I have a picture of a hot air balloon here because a hot air balloon works by, well, heating air. And when that air heats, that air expands, and that makes the air able to float above the rest of the cooler air that's on. So yes, I saw you're making water ice, that's fine. Cocoa mix for ice cream, it will make it chocolate flavored. Chocolate syrup is going to work better. Straight cocoa mix is going to be a little bitter, but you can still make it. Just might have to add a little bit more sugar. All right. So let me get into, somebody was messing with my screen. I don't know how they were doing that. So let me restart this. So in a moment, I still need to go grab my ice because I left that in my freezer. In a moment, we are going to be making ice cream, or if you so choose, water ice. If you're making ice cream, you're going to need some heavy cream, some sugar, and a little bit of vanilla extract, which I thought I had, but I did not. So I'm just going to have flavorless ice cream. Hopefully you have something to flavor it with. You can really mix anything in there for flavor. So if you have something like chocolate syrup works well too. If you want to have chocolate flavored ice cream, that will work well. If you're doing water ice, then you just need some kind of juice to put in your bag. So something like lemonade, soda would be good if you can get the carbonation out first. I don't want you to shake soda and have it like explode and make a mess. Or if you just have like Kool-Aid, Gatorade, anything of that nature, that'll work well for making water ice. So you have two options that you can make there, but I will be making ice cream. So give me 2 seconds. I will grab ice from my freezer because I didn't want to let ice sit out. And I will be right back on camera and we will start making our ice cream. Other things you will need, I have a measuring cup. Aside from the ice I'm going to grab, I have a small Ziploc bag and a large Ziploc bag. This is another activity because we are working with things that could be liquid. You don't want to do this near or by your computer. And I find that often these bags have a tendency to spring leaks if you're very rough with them, so be careful. With syrup or chocolate syrup for flavoring, Sophia? Yeah, you can use either vanilla extract or maple syrup. Yeah, it'll work. You'll just have maple syrup flavored ice cream. Whatever you put in there for your flavoring is the flavor you're going to get. So I'll be right back. I'm going to get my ice.
I see your question, Layla. We'll ask Mr. Cleary when he comes back with his ice. Okay. Ooh, apple ice cream. That does sound good, doesn't it? Yeah, you guys can make all kinds of flavors. Does anybody have like caramel sauce or anything like that? You could make some caramel flavored ice cream. Yeah, Emma, give me a moment and I will put the list in chat.
I thought briefly about making coffee flavored ice cream too, but I drank all my coffee this morning.
Mr. Cleary, Layla asked if they can use apple juice. Can she use apple juice today?
Yes, if you use apple juice, I don't think that would make good for flavoring ice cream, but if you just use apple juice to make water ice, you can have that. That'll just be apple juice flavored water ice.
All right, so there we go.
So I'm going to start by putting things into my small bag. Be very careful when you're pouring things in here, just so you don't make a mess. And it is about 1 cup of heavy cream for 3 tablespoons of sugar. I should be measuring this, but I'm just kind of eyeballing. Now I'm going to put some sugar in here. Ice cream does have lots of sugar. So I always tell kids, when I was younger, I had a neurologist, somebody who studies brains, tell me I need to eat more ice cream because there is a fat in ice cream that is the same fat that most of your brain is made out of. So having this kind of fat is very good for brain development for children. So tell your parents, hey, science says I should be eating ice cream. I'm going to stop screen share so you guys can see my demonstration here. Right now for my ice cream, I have just put heavy cream and sugar in a bag. I've sealed this up and I'm just kind of mixing it about. If you have vanilla extract or chocolate syrup, mix some of that in there as well and just mix the ingredients together a little bit. If you can very carefully squeeze as much of the air out of your bag as you can. The way I do this is I kind of make a small opening, I squeeze it a little bit. Once the air is out, I will seal it. So now I got a bag with some heavy cream and no air. And if you are using juice like Kool-Aid or apple juice, just pour your juice straight into the bag because you're not really mixing ingredients together like you would for ice cream. Now, the other thing I forgot my salt. I need to grab that. That's important.
I will say, as someone who has done this before, it will get a little messy if it's not completely sealed. And as Mr. Cleary gets his salt, don't add too much salt or else you'll have very salty ice cream.
I'm like low on this salt, so I got another salt. Anyways, salt is important because when it is wintry and it is cold, what do they put out on the roads to make the ice go away?
A lot of people are saying salt.
Mm-hmm.
Yes, and it's not the same kind of salt that you eat, but it is a salt. So don't eat road salt. But it works the same way as what we're going to use.
Mr. Cleary, folks are asking about amounts. So how much sugar, how much salt, how much cream?
It is about 1 cup of heavy cream and 3 tablespoons of sugar and less than a half teaspoon of vanilla extract because that stuff is very strong.
By the way, real quick, for parents who are helping out, we sent an email yesterday at 3 p.m. that actually has a link to the PowerPoint that Mr. Cleary was sharing with all the instructions, all the measurements, everything like that. If you want, you can pull that up. If for some reason you didn't get that, I'm here, email me right now and I'll email it to you right now.
Now in my large bag, I'm going to put some ice. I want this to be cold because ice cream is cold. We're going to put a lot of ice. And what we want to do is we want to melt the ice with the salt, just like they do on roads. Because when that ice melts, we have all this cold, and the heat is going to get into the ice when it melts. But the heat has to come from somewhere. You can't just have heat come from nowhere. So we want the heat to come from our bag of cream or of flavored drink. So we have ice and we mix it with salt, that will force the ice to melt, and that will draw heat from its surroundings. It's going to super cool everything. So I'm going to put in ice cubes everywhere. Good amount of ice. All right, I got a lot of ice in my Ziploc sealable bag. Now, the other important thing to be careful of, you do not want to be too rough with your ice because you do not want to break your bag. You do not want to screw a leak and get things messy. If your tiny bag, if you are too rough with it, springs a leak, you're going to get a lot of salt and you're just going to have very salty ice cream or very salty drink. And unfortunately, you will just have to start it. So you want to mix this about, but do be careful. All right, I'm going to add a good amount of salt. I'm really just going to pour the rest of this salt container in here because there's not much left in here. So maybe about a cup's worth of salt in your bag of ice. And that salt container is done. All right, I didn't need the second. Maybe a bit more ice. Now, before you put this bag in, make sure that it is perfectly sealed. Run your fingers amongst it. If you're daring, tip it upside down, see if it doesn't spring a leak anywhere, because you don't want this to be open anywhere. As you can imagine, we're going to put this bag inside of our other bag. Push out some of the air and seal it. I hope you guys are ready for a workout today, because next we need to shake. Maybe not too vigorously, because again, you don't want to be too rough to make a hole in your bag. So I like to kind of just roll it around. Mix the ice, mix the salt. You're going to feel it's going to get very cold in your hands. If you need to put it down and trade off with somebody, you can do that. Or hold it, don't drop it. Hold it by the top, just shake it a bit. And you're going to do this for a while. Now, for the people making water ice, lucky you guys, this is going to go a little bit faster. People making ice cream, this is going to take a little bit longer. Take it back forward. Again, not too rough. You don't want to break your bag or spring a leak or get salt in your sand. All right. I'm going to give mine a check. So I'm going to carefully open it up. And I can tell it's making progress. Not quite there. We're going to put it back in. And get back to it. And I know it is getting colder because I see I have a lot of water in here. That means that the ice melted. When the ice melts, again, makes the things around it colder.
Mr. Cleary, if they're using juice, do they need the sugar, or is the sugar in the juice already?
Sugar is probably in the juice already.
Okay.
Ice cream, you have to add a bit of sugar because then it just takes very creamy, but not very sweet. So if you have ice cream made already or water ice made already, hold it up to the camera. Mine might take a while, and I added a lot to mine. Not screen, it's right. That,
Guys, if you keep on
It's cool.
spamming chat, our next recipe is going to be making broccoli. Just letting you know.
all right, so gotta, my fingers are rest here now. Then I think mine might be ready. I'm gonna open it back up. See, oh, yes. That looks pretty good. Now, your tiny bag is probably very wet. It's covered in salt water. So I'll show you what to do if you want to eat this. Yeah, if you didn't measure, I saw somebody say like you didn't measure the ice, that's fine. The ice measurement doesn't have to be exact. You just need to have some ice and a good amount of salt in there. Now to open this bag up, you don't want to get anything from outside the bag inside. I will open it up. And oh yeah, that's ice cream, all right. Most of it, at least. And you want to eat it just straight from the bag. So mine could maybe go for a little bit longer. I will save this for later. I'm going to put it right on top of my ice. Does everybody else have a ice cream or their snacks made? If it's not frozen yet, keep shaking at it. It'll get there eventually. If you need instructions, I will screen share my instructions again. I'm going to put the ice back into my freezer so it does not melt.
So guys, your parents should have a copy of this recipe in their email. So don't fret, don't worry. Your parent should have a copy of it so that you guys can double check those amounts and make sure that you know what you're doing. How's everybody's stuff turning out? Has anybody eaten their ice cream yet? How does it taste? How'd that maple? Yeah, I agree. I really like ice cream too. So let us know how things are tasting. Could always put some toppings on it. Does anybody have any sprinkles that they're going to put on their ice cream or?
Sprinkles, that sounds lovely.
Everybody seems to be enjoying their ice cream, Mr. Cleary.
Good, good. Now for the next activity, we work with something very cold. Now I'm going to give you instructions on how to make something very hot, make an oven. And this one doesn't use any gas or electricity. It uses the sun, so it's safe for you to use. Is everybody ready to move on, or are you still working with your ice cream?
Very quickly in chat, put in what flavor you made.
Okay, some people are still waiting. If it's taking a while, actually add a little bit more salt, might help it speed up that process. Inside the small bag, I put in cream and sugar to make ice cream. So we don't want to have a lot of salty ice cream. So we put that in a small bag, we seal it up. And then in a larger bag, we put ice, salt in that smaller bag. Do I have a cat? Yeah, he's right here. He jumped in to interrupt. He's not camera shy, that's for sure. He also messed with some of my lab materials yesterday. So I'm gonna have to ask you to leave. Dexter, get out of my lab.
All right, I'm seeing some people eat the ice cream, and it's very, very funny to see the reactions of people to realize how well it turned out.
Yeah,
Nyla and Nate, looks like you guys are really enjoying it. And
good.
if you didn't get a chance to make it, you can make it later today or tomorrow. We'll post this on YouTube. We did do this last year as well. Did anyone make water ice? Did anyone, instead of making ice cream, make water ice? If you did, put it in chat.
Fruit juice ice cream. That sounds good.
Hey, Aubrey says she's doing it, but it's not working. Do you think that's not
If it's
enough
not
ice?
working, you probably just have a lot of water in there that needs to be frozen and not enough ice or salt. So add in a little bit more ice into your bag or a little bit more salt to speed up that process. And it will get there. It just takes a while. You might have to keep shaking at it. My ice cream was still a little bit melted, actually. So I just set that aside to finish freezing somewhere else. And that's another thing. If you put it down, it will, with the ice, salt, and ice cream in the bag, it will still freeze over time. So you can put that aside while we move to our next activity here, which is making a solar oven. So I'm going to once again move to my lab station over here. And I have these directions in the PowerPoint, and I will show these again later, but I'm going to go back to my camera so everyone can see how I made this solar oven here. And put all my food stuff aside. I have all this water, salt on my table. This is what the final solar oven is going to look like. I made an example one to test it out last night. Ideally, you can go and you can put in some item in here that you would like to heat up. Place this out in the sun. And then it will cook whatever you have in there. You might need something to help prop it up. So this is my example. I'm going to make a second one to show you how to do it. So I said a pizza box works best. So I had pizza last night. And then if you have a pizza box, that's great. If you don't have a pizza box, any other kind of box will work. We just need to cut a hole or a flap into the box for an opening. So if you have like an old Amazon delivery box or a shoe box, that will work as well. Pizza boxes just work best because they're already flat and cover a wide area. So the first thing we need to do is we need to cut not a hole, but a flap in our pizza box. So you can use either scissors. I have a X-Acto knife, so be careful if you're using something sharp. So be the only cut that we have to make for this. I'm going to cut probably kind of around the perimeter, the logo here. So we're going to cut kind of 3 lines here. Right there, that's one. Yeah, every bit of energy that we have on Earth, in one way or another, comes from the sun. The heat comes from the sun, and then if you eat food, you get energy, and that energy comes from plants, and plants get their energy from the sun. Or if you use electricity, that electricity might be solar powered, or that electricity could be from something like a fossil fuel like oil or coal, which at one point was a living thing, probably a plant, just a very long time ago, that got energy from the sun. So all energy, with very few exceptions, comes from the sun. And we're going to use the sunlight energy to cook food for us. But here I have in my pizza box one flap. This up here. There we go. I can move a bit more graceful, but I have a flap. So I don't want to cut this whole thing off. We're actually going to use this piece. So my wax paper. The next thing we need, I'm going to put all my ice cream stuff aside. The next thing we need is aluminum foil. Aluminum foil is going to do two things. Aluminum foil is going to act as an insulator, so it's going to help to keep the heat inside of the box. It is also reflective. So we want something to act as we want something to act kind of as a mirror to reflect and shine the light where we want to go. And aluminum foil will do just that. So if I open up my pizza box to the inside now. The next step I want to do is put aluminum foil inside of the box. So I'm going to pause real quick because I think I'm going a little fast to make sure everyone's caught up with me. I think some people are still cutting their flaps out.
So remember, guys, just cut 3 sides for your flap. You still want it to be attached. You don't want it to come completely off. So you only need to cut 3 sides. And of course, you can, ask your adult at home if you need a little bit of help with the cutting part. Adults are good for that sort of thing.
Yeah, I used a knife, which you probably don't have because it's super sharp, but it made my job a lot faster. You can cut it with scissors. It's just gonna take a little bit longer. You might have to stab it in there to get started.
Mr. Cleary, do you want to give them some adaptations if they just have a cardboard box that maybe have those have the 4 flaps across the top? How would they work with those flaps to give them the flap that they need? Like if it's an old Amazon box.
Good question. You could always do this kind of flap in the side, but there's probably a way you can adjust the flaps that does this. Because what this flap does serve a purpose. We want this to be facing the sun, and we want this to reflect sunlight down into here. So that's what that is for.
I wonder if they would need to take the box and sort of tape it so that the top is completely flat and sealed, and then maybe cut the flat or the flap once they sort of tape the top to make it one solid piece. I don't know. I'm just making stuff up.
Yeah, I don't think you want to make it one solid piece. Probably something like putting 2 of the side flaps down and removing a 3rd one. Because then you can just have the 4th flap be the one that moves up or down.
There you go. That makes sense.
So, and I can't really demo that because I don't have an Amazon box, but you want to have a flap. So I already saw some people getting ahead. I will go on to our next step, which is to line the inside of the box with aluminum foil. And you want to get it kind of tight in here, and that's going to act as an insulator. Most instructions have you taping the aluminum foil down. I just kind of wrap it in there, kind of stuff. And the other thing we will need to put inside of the box, we want to conduct heat. And something that conducts heat very well is something that is dark in color. So I have a black piece of construction paper. Light fit in here, so I'm going to fold it so that it fits most of the bottom. So construction paper will turn light into heat. The aluminum foil will keep that heat inside. And then if I have that done, I can close my box. So I have aluminum foil, and then I put something dark in there, like black construction paper or something like a dark piece of fabric, anything that's like dark in color, put down inside here. Down. I'll give people a few moments to catch up. And my phone's over there. What time is it now? Again, how much time we have?
It's about 10:40.
Okay, so
So about 20 minutes.
Okay, so we can wrap this up shortly. See, some people are still eating their ice cream. Glad that turned out well. Now I'm going to close my box. Be careful with the aluminum foil there. And this flap, I want to add aluminum foil to the bottom of there. Again, that's going to reflect sunlight down into the box. This is maybe where I'm going to want to start using the tape. Try and get the aluminum foil very flat for this part. That's going to help it reflect a lot better. I just have some Scotch tape. I'm going to just take the aluminum foil down around behind it. If your flap is not staying upright very well, you want to be kind of at a 45-degree angle, which mine kind of is. If yours is like closing all the way, that's not good. You can use like a popsicle stick or something, put it here to prop it up. Or just a stick from outside even would work. All right, we are down to our final step. So I see some people are still working with their aluminum foil. The final step is saran wrap. I can't read the chat from here, but if there's any questions or anything, read them out loud to me. But or any responses. But does anybody know what a greenhouse is? What do you find in a greenhouse? Yes, you find plants. And greenhouses are great for growing things because you can grow things even when it is very cold outside. Greenhouses allow light to come into the greenhouse and then they trap heat. And that even has its own name. It's called the greenhouse effect. So we are going to be using the greenhouse effect for ourselves. Have you ever gotten into your car or your parents' car on a very hot summer day, and then the inside of the car was really, really hot? That's the greenhouse effect. The light can go through the windows of the car, but then once light goes in, heat cannot leave. So we are going to use this to our advantage. the saran wrap is going to allow light to pass through. You definitely want to have clear saran wrap for this. It's going to allow light to pass through, but it's going to trap the heat inside of your box. So I'm going to take a piece of saran wrap. I'm going to cut this. There we go. And I'm going to place the saran wrap over top of the hole in my box. And tape that down. And you want to tape it so that there is no openings, no holes whatsoever around the saran wrap. Tape it all the way around the edges. You can have air escape and you can have heat escape. We don't want our heat to escape. I'm still going to tape it so that I can open the box for my pizza side. Try and make it a little tight here. Tape. All right. And now I can't open it. I should tape it shut. I'll fix it. Maybe tape it even to the bottom of the flap so we don't have air being able to leave from that way. There we go. So now I have my solar oven. The sunlight is going to come down from the sun. Is going to either go straight in through the saran wrap or hit this and be reflected down into the box. That sunlight will then hit the black reflective piece of construction paper I have in there, which will absorb the sunlight and turn that light energy into heat energy inside the box. Then the heat will be trapped by the aluminum foil, the saran wrap, and the box itself. And the inside the box will get very, very hot. Now you may be thinking, how hot can this get? Can I cook something in here? Well, I have not cooked something in here before myself, but I will tell you I have done this before. And on one particularly hot summer day, I made this very same item. And to test it out, I took it outside and I put a thermometer in there, like a regular glass thermometer. 10 minutes later, I went outside to check on it, and the thermometer broke. It got so hot. So it can get pretty hot in here, well over 100 degrees. All right, I'm done building at my craft table here.
Mr. Cleary, what would happen if they put a marshmallow in their little pizza box oven?
So this is not going to be as effective as a fire, so you will not burn a marshmallow or catch it on fire, but you will probably melt a marshmallow. It will definitely get high enough to melt a marshmallow on a good hot summer day. So not a burnt, but a melted marshmallow. Bunch of good, yes. So this is actually a good way to make s'mores. You can put some graham crackers with some marshmallows inside of there, and then let them sit out there for a while, and then take it out, put a chocolate bar in there, another graham cracker, you have some s'mores.
I think we actually have a student who did make s'mores in the past. I seem to remember in the chat somebody said they made a s'more in their oven. Mr. Cleary, we've had a request to see the slide about states of matter again. I'm not sure if you want to do that now or closer to the end.
Yeah, I'll do that closer to the end because I wanted to put this slide up if somebody wanted to see the directions written instead of me going through it.
There we go.
So you have a nice diagram that goes along with it, showing how it works.
No, you could not. You could not start a campfire with this, Dylan. It just does not get that hot. So this is more like a warm than a really hot.
It is possible to start a fire with the sun, but you normally do that with something that is reflective. Like you may have seen people do stuff with magnifying glasses. This does not do that. It does not focus the sunlight enough to start a fire. It will collect a lot of heat from the sunlight though, so we'll get things very warm. Probably comparable to the inside of your car when you go inside your car and it's very hot. So some things you can cook with it. S'mores, probably number one thing. You might be able to like heat up a Pop-Tart, maybe not toast it, but like get it nice and warm. Or anything like leftovers. You want to just like heat up some leftovers and you want it to take a very long time. You can put it in there for like 30 minutes instead of a microwave.
Mr. Cleary, how long would you leave this out in the sun to get a nice warm temperature?
It's really going to depend on the amount of sunlight, how direct the sunlight is. It's going to work best if you have it facing the sun this way. So if the sun is like towards the camera here and going directly in the box. On a cloudy day, it probably won't even be noticeable. So like today, unfortunately, there's a lot of overcast. Probably wouldn't work too well today. Save it for a nice sunny day. But a nice sunny day, I mentioned it was hot enough to break a thermometer after about 15 minutes.
All right, guys, do you have any other questions for Mr. Cleary right now?
Oh, the end of Ghostbusters. Ghostbusters is my favorite movie. Yeah, you can definitely cook something in 1 hour. If you want to try putting in, trying to think of something I could cook, like you could try putting in something like so anything you put in an oven, like some vegetables, you could put in and see if you can like bake some vegetables. Or I wouldn't put in raw meat, but like if you want to reheat something, so like bagel bites or some chicken nuggets, try putting those in, experiment with it.
Carly's asking about brownies. You could probably warm a brownie up so you could put the ice cream you just made on it, and it would be a warm brownie with ice cream.
Frozen foods are safer than baking because baking tends to have very specific temperatures for specific times. And unfortunately, with our solar oven, we cannot control the temperature. It's either very hot or in the middle. But I had somebody say something about states of matter, and wanted to go, and I had this link I was going to give, because I know our electric circuits was so popular the day before. So if anyone would like to experiment with different states of matter, you can check out that link. And I can go back, I know somebody said they want to go back to this diagram for the states of matter for solid, liquid, and gas. So not a whole lot of time to get into our simulation there, but I know the electric circuits simulation was a big hit, and this is a similar one where you can observe the molecules going from solid, liquid, and gas. Change both the temperature and the pressure. I know, PhET Labs is phenomenal. As a science teacher, one of my favorite websites.
All right, so guys, I think we're about ready for our morning break. Are you ready, Mr. Cleary, for us to take a little break?
Yeah, I'm hoping my ice cream is cooled a little bit more now and ready to eat. So I'm going to eat my ice cream while we go on break here.
Okay, so everybody, this is our little break of the morning. Turn on my camera. So this is your chance to go check on your ice cream again. If you want to see how it's doing, you can, take a little stretch break, go get yourself a drink. So this is your little time to do that. I will stay here. I'll be hanging out on camera. And for those of you who are hanging out here, maybe we'll do something fun. I do want to remind you guys, we will be starting back up at 11, maybe a couple minutes after, since we broke a little bit late. We do have more summer camp sessions coming up. So those are on our website and our Facebook page. We also have the link to download that summer passport. And we're far enough in. If some of you have attended all the sessions, you could have everything filled out on your passport and send it in. So you might be winning a prize already. Tomorrow's camp session is Introduction to the Human Body and Mind. And guess what, guys? Mr. Sheik, I know you love Mr. Sheik. Mr. Sheik is going to be joining the session live from the Franklin Institute. So, so tomorrow is going to be super, super fun. You guys know how much fun Mr. Sheik is.
Real quick, Miss G, pardon me. You're in here, Miss G, right? Are you connected? Woo.
Yes, I am here. I'm getting my stuff ready for when we make cheese in a little bit.
All right. Does anybody have any questions for Miss G as she's getting stuff together before we start at 11 o'clock? Because I also know everyone has a snack because we made snacks. We made some ice cream, so you should have some snacks or some water ice. And if you don't have any questions, that's okay. But I just thought I'd ask since Miss G is here. List of supplies for each session are sent via email, Nyla. So you should have them. You know, we sent them yesterday. We sent them last week as well. This particular one was a little different. So we sent that yesterday. Is that we're going to do with Miss G as far as making cheese. So you should have them in an email. And awesome, Carly. You said you had all your sessions scanned out. So I imagine you mean about the passports. That's great. And I know we normally do a little thing here when it comes to stretching. So for all of you that are still in front of the computer and you need to move around, you know what time it is. Put your hands up, put them up, put them up, put them up, put them up, and wiggle around. All right, wiggle around. Okay, we're gonna make a T. Make a T. And then we make a funny sound. All right, one more time. Put your hands up, put the hands up, put them up, put them up, put them up, and wiggle around. All right, now we make a T. Get your palms up, pull your palms down, and make a funny sound. All right, so hopefully you guys got a little stretched out. We still got about 2 more minutes. So, you know, if you have to use the potty, if you want to get a little snack, see Iggy and Eli over there, they're drinking something really nice. Wonder what they're drinking.
And Ms. G was kind enough to put the materials list in chat for everybody. So that's in there if you guys need it.
And Harmony has an awesome lollipop. A lot of people got some dishes and snacks. Layla has one too. Oh man, you guys came with the snacks today. All right. Whoops. And I accidentally went to full screen mode, so I couldn't see all of you. Anybody else got some interesting snacks? You can put it in chat if you got some interesting snacks. Because I'm looking to change up my snack game, mix something new in there. Snacks to get boring if you stick with the same stuff. All right, guys, one more minute. So we are back officially.
So I cheated a bit with my ice cream, which is fine. It's my ice cream. And I mixed some real ice cream in there because I did not have any vanilla flavoring. The ice cream tasted good, but it was just flavorless ice cream. So I'm hoping my vanilla ice cream mixed with homemade ice cream gives me homemade-ish vanilla ice cream.
We got to see what the ice cream looks like. That looks like ice cream. That looks like real ice cream right there.
It's a little goopy.
No, Carly. Dexter does not need any ice cream. Dexter is hyper enough. He doesn't need any sugar.
He is right.
As he comes, he heard his name. Here he is.
Got our cat cam on.
This is officially just going to become the cat break.
I was gonna say Dexter's the real star of the show.
Yeah.